Welcome to September's Leetcode challenge. Today's problem is array nesting. You are given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. Now, you should build a set S of k equaling all these various nums of k, then nums of k, then nums of k, and so on and so forth. Now, the first element starts with the selection of the element nums k, or index equals k, and really all this description is kind of going to be confusing. Let's just look at this example here. So notice that we have a permutation of numbers from 0 to 6, right? So there's 7 numbers, and each one of these represents an index. So let's just say we started at index 0. We're going to go from index 0 and move to index 5. Then we're going to move to index 6. Then we're going to move to index 2. Then we're going to, I'm sorry, here, this one, index 2. And then we're going to move back to index 5, right? So you can think of that as all those are in a set here, 5, 6, 2, 0. Now let's think about some characteristics of this nested array. Now one of the first things we should realize is when the index number and the number itself are the same, that means there's no way to get to there. So for instance, right here, 3, that's number 3, and that's at index 3, right? Maybe it'd be better to also include like this. Well, that means no matter what, there's really no way to get there. Like whatever we traverse, this 3 is kind of on its own, right? So at first glance, I thought, well, maybe we just go through this array and check to see which ones don't equal the number. And if that's the case, maybe that's all it is. This would be like 6 because everything else is different, right? But unfortunately, that doesn't work because as we saw in our example, if we go from here to 5 to 6 to 2, it's only 4. We're missing out on this one, and I believe it's this one. Like these two are their own set here. So what's going on there? Well, basically, this permutation here, because all these numbers are unique, it's not guaranteed necessarily that every single number is going to connect to one another. Like they might be in their own separate sets. The only thing that we can say for sure is if the number is equal to the index, that means there's no way to get there. So what we can do then, knowing that fact, is write a recursive method, and starting at each index number, we'll traverse and mark each one of these indexes that we visited in some sort of set. And once we've finished that, we're going to return how many numbers that we've like traversed. Now that kind of means that everything that we've seen so far has already been marked. So 0, and then, or actually not 0, here would be 5 would be marked. Or actually, I guess 0 would be marked, and then 5 would be marked, and then 6 would be marked, and then 2 would be marked, and then we try to go back to 0, but we've already seen that. So all 4 of those are now going to be in its own set, and then we're going to check to see, all right, well, what about 1 here? We'll check to see if we visited that, and so on and so forth. Now, my first approach here was to just do this in a dynamic programming fashion. What we can do is we'll create a set called scene, and we're going to write a helper method here, and I'm going to call it recursion. You can call it whatever you want, and I'm going to input the starting index that we start at. All right, so if, let's see, start is not in, or not is, if start not in scene, then we're going to add this start here. Then we'll, let's see, basically just return 1, which counts as this, and recursively call the next one, which would be nums of start. Now, otherwise, if we've seen this before, we just return a 0. And let's make sure to do a LRU cache here and memoize everything so that we don't do any repetitive calls. Finally, we just need to do this for every single index number, right? So for I in range of length of nums, we are going to call our recursive function for every single one. And we want to return the maximum here. So this was my first approach, and let's see if it works. Looks like that's working. And that does get accepted. So this is O of n, time complexity, and space complexity would be the same, although we do have 2 O of n's here. We have the set and we have the recursive stack, right? So it's not very efficient, unfortunately. Yeah, it does pass, but you can see it's not very good. Now, one of the ways that we could make this a little bit better is rather than doing it recursively, we kind of already see that we can probably do this iteratively as well, right? We don't need necessarily this recursive call. So instead of doing it like that, what we might do then is we'll still use the scene set, but we'll say, let's have our output, which will start off with 0, and we'll have, we'll say for I in range of length of nums. Let's have a nested loop here. We'll say, let's see, while I not in scene, we're going to add I here, and we're going to update our I then to equal the nums of I. And let's have a temporary variable here. We'll start with 0, and we'll increase this every single time. And then all we have to do is set the output to equal the max of output and temp. And this should work as well. Let me make sure it does. And that does look like it's working, so submit it. And there we go. So that's a lot faster. You'll see that it's like a lot faster. Although time complexity technically is the same, but I suppose it's because of all those recursions that it gets a little bit slower. So now one more approach. You could also save space instead of having the scene set here. What we might be able to do is, why don't we use the original array to mark the ones that we visited instead? That way we don't even need this scene set. But to do that, we'll have to do a little tricky things. What we'll have to do then is we'll have output equals 0, and instead of this temp, what we're going to do is mark a starting point with I, right? And we'll say, okay, while start, or I should say, while nums of start does not equal something, like we'll say -1, because we know that all the numbers here are going to be at least 1 to whatever, or I'm sorry, 0 to whatever the length is. So instead of doing the scene.add, what we'll do, let's store this as the previous, and we are now going to update start to equal nums of start, and we are going to say, all right, nums of the previous number right here, mark it as -1, so that way we know we've seen it before. And this should be the same. Let's make sure I didn't mess something up here. Okay, that does look like it's working. Submit that. All right, great. So that works too. This is still O of n, but it's going to be constant space, right? Because we modify the original array. So it's really dependent on whether we're allowed to do that or not. If we're not, then unfortunately we have to have some other data structure to know which ones we visited so far. Okay, hopefully that helped. Thanks for watching my channel. I really appreciate it. And remember, do not trust me. I know nothing.